Hello! In this video, we're going to be talking about determining limits using their properties, aka what sort of sneaky tricks we can get up to in order to be able to determine what a value of a limit is. Okay, so to talk about these properties, I'm going to keep this the same all the time and these the same all the time, just kind of as my toolbox, so I can demonstrate how these different rules interact. Our first rule is if we've got just like a number that's inside of a limit, we can take that just number that's being multiplied by some function and put it in front of that limit. So here we've got this 5 with our g. We can take that 5, put it in front. We know that the limit as x approaches c of g of x is 2, and then, 5 times 2 is 10. So if we look at this next example, we can say, hey, that's 3 times the limit of f of x, and we know the limit of f of x as it's approaching c is 16. So this is just 3 times 16. So our limit is 48. Our next property is similar, but a little bit more wild, is if you have an exponent inside of a limit, you can actually pull that exponent and do the whole limit to that particular exponent. In this case, a 3/2 was able to be outside of the whole limit. Now, this is kind of like a little goofy notation, similar to when we saw sine squared in pre-calculus. This means the limit as x approaches 4 of g of x, and then that g of x is getting squared, but you see how that's like a lot of parentheses? What's going on over here is like a little mathematical shortcut. So just like in the one above, we can just square this whole limit of g of x like so. So let's see, this is as we're approaching 4 for g of x, so that is 3. So this is just, that should be a bracket. So this is just 3 squared, which is 9. Nice. It even works with square roots because square roots are just 1/2 exponent. So this is the limit of f of x to the 1/2. This is as x is approaching c. As we can see down here, that's 16. So this is just 16 to the 1/2, which is the square root of 16, which is 4. And that's my limit. This next property is used quite often. If you see that there is a sum or a difference inside of that limit, you can break it up into 2 separate limits that you can find the value of. So here we broke it into this limit, and then we just added those two together. So this is the limit as x approaches 4 of g of x plus the limit as x approaches 4 of 3. Well, we know what the limit of g of x, the limit as x approaches 4 of g of x, we know that to be 3. In that other one, you can see how like that x doesn't even show up. If you ever do the limit of just a constant, it is just going to be that particular value because the x isn't changing. As x is getting closer and closer to 4, it's just stuck at everything the function is doing is 3. It's 3. It's 3. Okay, well, it's just 3. So that's 6. Our next property is the product rule. If you've got two things multiplied together, you can make them two limits that are being multiplied together. So right here, I can make this the limit as x approaches c of f of x multiplied by the limit as x approaches c of g of x. I can find those two limits separately rather than multiplying those two things together and then finding the limit. So this is 16, kind of stealing this from the bottom, and then this is 2, so this is just 16 times 2. So this limit is 32. Our last-ish property of limits is our quotient. Similar with multiplication, we can do the same thing with division. So if we've got two things being divided, we can make it a top limit. So we get this limit of g of x over the limit of f of x minus 1. But hey, that's a subtraction. We talked about that earlier. We can break that up into two things. So we got the limit of g of x And then we've got the limit of f of x minus the limit of 1. Okay, well then just do all those bits. So g of x, and as we're approaching 4, g of x as we approach 4 is 3. F of x as we're approaching 4 is 0. And if you do the limit of a constant, that is just going to be 1. So we've got 3 over 1. So this limit is 3. Now, I've been saying it a few times, but it's important to point out still, if you have a numerical limit, if this is just a constant, as x approaching c, then this is going to be that constant. We're going to apply our different properties together in this problem, and probably this one here too, in order to figure out what is going on with this limit. So the first thing I see is I've got a fraction. So I'm going to break that up into two limits. Okay, so now I kind of want to like break up what's going on with the top and the bottom. So the top, I've got a multiplication, so I'm going to break that up into two separate limits. On the bottom, we've got that square root. So that square root tells me that I can pull that exponent out, okay? So I'm going to make a big kind of bracket with a 1/2 exponent. And then break up those two pieces that are inside of the limit. Okay, two pieces broken up. I can't break this up anymore. It is just time to knuckle down and start doing some of these limits. This first one right here is just a constant. So the limit of a constant is just going to be that constant. So this is 3. We've got another one of those right here. The limit as x is approaching 7 of 2. It's just a constant. So that's 2. Now these ones that are x, these ones, what do you think that limit is going to approach as x is heading towards 7? So as you're just moving towards 7, what do you think x is going to approach? It's sort of a question of what color is George Washington's white horse? Who's buried in Grant's tomb? Grant, Washington, white, it's 7. So that they're there. Now just do the math now. Okay, so this is 21 over 7 plus 2 is 9, and that's being square rooted. So that's 21 over 3, so that's just going to be 7 as our final answer. This limit, oh really? It's just 7? Oh man! As we head towards 7, it's 7. Well, that was lucky. That was not where it was supposed to. That was just lucky. In this example, we want to see where is this limit heading towards. Okay, so let's break it up as much as we can. The first thing I see is I see a bunch of additions. So I'm going to break those up into separate additions. Now, the next one I'm going to do is I'm going to deal with this one because that one's pretty easy. So those are two things being multiplied together. I can break that limit up into two separate limits being multiplied together. Oh. There we go. This one, there's nothing really to do with that. So I'm just going to keep that as a limit for now. It's going to be 1 in a minute, but whatever. Then I still have this one over here. So I'm going to break that up into two separate limits being multiplied together. So now I have the limit of as x is approaching -3. All of these have x is approaching -3 on the bottom. Limit of 2, limit of x squared, limit of 4, limit of x, limit of 1. I could do one more step with that x squared. I could break that up. Into a limit of x and then square that, just like that. Okay, cool. So now I got limit 2. I got plus all this stuff. All right, knuckle down time. Time to just do these. All right, so the limit if you're approaching a constant is that constant. So this is 2, this is 4, that one's 2 right there, and this one's 1. So we're going to have this plus, and we're still going to have this one. All right. Now, right here, the limit as x is approaching -3 of x. If you're approaching -3, limit as x approaches -3 of x. What is x heading towards as x is heading towards -3? Well, it's heading towards -3. Same thing here. Limit is approaching -3 of x. Well, where is x heading towards as x heads towards -3? -3. Although this one's got a squared on it, so let's not forget that squared. So we get 2 times 9, which is 18, minus 12 plus 1. So that's 8 minus 12, that's 6, plus 1 is 7. That's it for our properties of limits. Reminder that you can multiply out, you can pull out exponents, you can split them up with addition, subtraction, multiplication, and division. Also, if there is just a constant left after you do all that manipulation in there, that limit is going to be just that constant's value. Thanks for watching this video on properties of limits. You have a great rest of your day. Bye-bye.